Hey, Stepster.
Cheers.
I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today, we'll be looking at fractions and how you can convert decimals into decimal notations into fractions or vice versa.
So let's get started. So let's start off with talking about fractions. So we know a fraction is a part of a whole. Like we learned about this earlier, where in probably elementary school or primary school, however you guys say it, where I gave you an example, or we usually use the example of take a pizza and it's cut into 8 slices. A fraction would be if I take off one slice of those of the pizza, then that would be 1/8 of the pizza if the pizza was in 8 slices. And I'm pretty sure you guys did something similar to that too. So that is what a fraction is. Now let's talk about proper and improper fractions. So proper fractions are when the numerator is less than the denominator. For example, one of the most common proper fractions would be 3 over 4. Here the numerator is a smaller number than the denominator. And an improper fraction is basically the opposite, where the numerator is greater than the denominator. For example, 7 over 4, or even 5 over 4. And pretty simple, right? So you can also look at these as if we draw a circle and then we can shade out parts, right? So 7 out of 4, the reason why it is improper is if you use my example for pizza, if a pizza is in 4 slices, how in the world are we supposed to get 7 out of that, right? That is why it's improper, because with real world examples, it's going to be a little difficult to um, visualize it. So now we can move on to mixed fractions.
Yep, now let's look at mixed fraction. So for mixed fractions, you have a whole number combined with a proper fraction. Example 1, 3 over 4. So you write it like this. It's 1, 3 over 4. You usually write it like this to better like look at the whole number and the fraction. So how to convert? So first let's look at an improper fraction and convert it into a mixed fraction. So let's take an example of 11 over 3. So you might wonder, oh, well, how can we convert it into a mixed fraction? So first you look at how many times you can like go multiply 3 with another number to get close to 11. So you can say it's 3, right? Because 3 times 3 is 9 and 3 times 4 is 12, and that's more than 11. Do you want to be below 11? So that's 3. So you just write 3 to the side. That's the whole number, right? And then now you need the fraction part. Now you look at the remainder, right? 3 times 3 is 9. And then 11 minus 9 is 2. So you just put 2 there. And then you divide that by the number you already have in the denominator. So it's just 3. So that's how you convert from a improper fraction to a mixed fraction, right? And then now let's look at how you can convert from a mixed to an improper. So this is a mix, right? Let's just take the same example. And what you need to do is first multiply the denominator, which is 3 in this case, and multiply it with the whole number in front, and which is also 3 in this case. So you just multiply them together, and that's 9, right? And you take that 9, and now you add it with the number on the top of the numerator. So in this case, it's 2. So 9 plus 2 is 11, right? You just put that in the numerator. And now the denominator in this case, again, it's 3, right? You just put 3 there. See, you got the same answer we had from the start. So now you know how to convert from improper to mixed and mixed to improper. Now let's look at fractions on a number line.
Okay, so now let's talk about fractions on a number line. So we know that, okay, so now let's make a number line, all right? A fraction on a number line is just going to show, it's going to show you how to place proper, improper, and mixed fractions. And you can also use this while you're dividing between sec dividing segments between whole numbers. So if we were asked if there are two, so let me just visualize this for you guys. Okay? And this also helps you see which fraction is greater or which is less. So let's look at a number line, all right? Thank you. And here, okay, that was not a straight line. Here is our number line. If we want to look at fractions between, let's say, we have 0 here and we have 1, these are both, okay, wait, yeah. Let's actually do 1 and 2 so you guys can visualize it better. So let's say that's 1 and this can be 2, all right? So if we were ever to look at fractions that are between 1 and 2, one way that you can look at this is a lot of you guys probably look at your ruler and go, oh, this is 1 centimeter and 5 millimeters, right? And you guys look at that as, oh, this is 1.5 or this is 1.1. But those aren't fractions, those are decimals, right? So if we had to look at fractions, okay, here, I exited out of it. So I don't know what's happening. 1 second. Let me quickly just. Okay. I kind of just exited out of the screen, so it's not letting me write on it. But all right, let's just not question any of that. Okay. Or maybe.
Or do you want me to write on it?
Okay, so let's go back to our example of 0 and 1, okay? So if we had 0 and 1 on a number line, the way you can look at fractions between this is let's divide this space into parts. So let me divide this into, let's say, 1, 2, 3, 4, 5, 6, 7. Well, usually it would be 10 parts, but if we had 1, 2, 3, 4, 5, 6, 7, 8 parts on this, and we wanted to find a fraction between this, right? Usually it'll be 10 points, so we're just going by 8 because that's all I can draw right now. If we had something like this, then all you would have to do is we know that that would be something over 8, right? And if we looked at it from this way going up, we could say this would be 1 over 8, 2 over 8, which keeps going, right? And if you notice something, this 2 over 8 would end up becoming 1 by 4, and then there's 3 over 8, then 4 over 8 would end up becoming 1 over 2, which is half the way, right? We know 1 by 2 is half, right? Usually, like I said, usually it's going to be 10 spaces, and this is how I look at it. I usually just divide it into 10 blanks, and then every single time we're counting towards 1, towards a greater number, we're going to have that in our numerator. And when you keep doing that, you're going to get the different fractions between it, because they usually simplify and narrow it down. So if we had to do it from 1 to 2, we could use the same method, and this is, I think it's easier, and you could also visualize this with decimals. So if we had to convert 1 over 4 into a decimal, then that would end up becoming 0.25, which is between 0 and 1. And if you had to convert 1 point or 1 over 2 into a decimal, that would be 0.5. That's a way you can check that the fractions are between the numbers. And if you notice, you're probably like, oh wait, but isn't 1 over 4 supposed to be bigger than 1 over 2 because the denominator is bigger? That is not how it works, because, when you're dividing by a bigger number, you're going to have a smaller result. So if the numerators are the same and the denominator of one is bigger than the other, then the one that has a bigger denominator is going to be smaller than the one that has a smaller denominator, because you're dividing it by a smaller number. And that is a way you can look at it in a number line. And when you have to compare which one is greater and smaller, it just makes it easier when you look at it when you look at the denominator itself. And that also, sometimes you're going to have two numbers that have different numerators and different denominators, where you can definitely just divide. You could just look at it in decimal form. And the simplest way I would say is, every time you look at a fraction on a number line and you place it in a place, if you want to check that's correct, try converting it into a decimal. And that will make it a lot easier for you to just check and verify whether the fraction is correct and if it's in the right place in the number line. So that is all I have for fractions on a number line. And remember, I drew 8 spaces, but usually it's going to be 10. So you've try to visualize it if it's 10. So now let's move on to equivalent fractions.
Yep. Equivalent fractions are fractions that look different but represent the same value. So example is half equals 2/4. Multiplying or dividing both the numerators and denominators by the same number. And visual examples can be some shaded areas or different divisions. So let's look at an example they were talking about. So they got half equals 2/4, right? You might be wondering, oh, why are they the same fractions? They look different, right? Well, they said that if you multiply or divide by both the numerator and denominator by the same number, they're called the same fractions. So in this case, let's look at 1 and 2. What are we doing to get 1 to 2? You can multiply it or divide. You can't add or subtract. So you're multiplying it by 2, right? So whatever you do to the numerator, you should also do to the denominator. So let's multiply. What do you get? You get 2/4. So that's the same thing, right? So that's how you find that they're equivalent fractions, because you're multiplying the numerator and denominator by the same number. Let's look at another example. Let me erase this for making up space. Okay, let's look at 3/2. Now let's make like a fraction that is similar to this. Or let's take a bigger number. Let's try doing division this time. Let's use 12/6. Okay. Now we know that both 12 and 6 can be divided by 2, right? So let's divide both of them by 2. Numerator and the denominator. That's important. Or do we have a bigger number? Yes, we do. We have 3. So let's divide it by 3. Okay. Remember, don't do the mistake I just did right now. Always try to get the biggest number you can divide with to get to your simplest form. You can also divide by 2. Yes, they're going to be equivalent. But if the question asks you for like the simplest form, then divide by the greatest number. And that you're going to look at it more in the next like section for simplifying fractions. But for now, let's just divide it by 2. Because even if you divide it by 2, they still are the same fractions because you're dividing it by the same number. So 12 divided by 2 is 6, and then 6 divided by 2 is 3, right? So yes, this 6/3 and 12/6 are the same fractions. And that's how you know they're equivalent fractions. You can multiply or divide by the same number. Now let's move on to simplifying fractions.
Okay, so now let's talk about simplifying fractions. So simplifying fractions is reducing a fraction to its lowest terms. So while you're simplifying fractions, you're supposed to find the GCF of the numerator and the denominator. And the reason why simplifying is useful is because it makes the fractions easier to work with. So for example, if we had to simplify something like, let's say we have something like 12/9, we can simplify this because both of these numbers, or actually let's take Let me cross that out. Let's take 9 over 12. So the reason why it's easier to simplify this is because both of these numbers are divisible by 3. So we can divide the numerator by 3 and the denominator by 3 because that's a GCF of both of them, right? And it's also the greatest common factor because there's nothing else that you can divide both of these by. So if we do that, we're going to get 3 over 4, which cannot be simplified any further. And this makes it easier during addition, subtraction, and all of those calculations. So I would say try to simplify it as much as you can. Now let's move on to adding and subtracting fractions.
Yep. So first of all, let's look at adding fractions. So adding fractions, basically you do it when you have the same denominator. So let's say you have 9 over 12 and then 3 over 12. Okay, so you just add 9 and 3 and you just put the same denominator. So it would be 12 over 12 in this case. And that would be just 1. Same for subtraction. If you had the same example and they ask you to like subtract it, it's going to be 6 over 12 in this case. And that you can simplify more further, but for now, let's just say it's 6 over 12. And yeah, that's it for adding and subtracting fractions. But remember, if you have something like 9 over 6 plus 3 over 12, just remember that you can make 6 into a 12 by multiplying it by 2. So you multiply both the numerator and denominator by 2. That's going to be 18 over 12 plus 3 over 12. And you do the same thing. You just add 18 by 3, just get the answer over 12. That's it. And same for subtraction. Now let's move on to multiplying fractions.
Okay, I was on mute, so let's get started. Let's do multiplying fractions. So multiplying fractions, I think, is quite simple, where all you have to do is multiply the numerator and the denominator of both the fractions. And then and before you multiply, make sure you simplify both fractions to its simplest form. Because like I said, simplifying fractions makes it easier to work with. And if you're multiplying whole numbers to a fraction, you just have to multiply the whole number to the numerator and not the denominator. So for example, let's take 2 different examples. So if we have to multiply 3 over 4 times 2 over 11 for now. So if we had something like this, notice how you can simplify this, right? So when you're doing this, it looks like 3 times 2 over 4 times 11. And if you look at this, you can simplify 2 and 4, right? So this can be simplified to 1, and this can be simplified to 2. So if we do that, then this is just going to be 3 over 2 times 11, which is 22. So that is how multiplying fractions with each other would be like. But if we had to multiply something like 2 times 3 over 4, then in this case, you only have to multiply let me just take that 2 off, because let's take something like 5 times 3 over 4, okay? So if we had something like this, all we have to do is multiply the whole number to the numerator. So that would give us 5 times 3, which is 15, over 4. Pretty simple, right? That is all multiplying fractions is. Now let's get into dividing fractions.
Yeah, for dividing fractions, it's also pretty much easy. Let me just erase this for space. Yep. And for dividing fraction, you keep change flip rule. So let's say you have 2 over 3 divided by 4 over 5 in this case, right? What you got to do is you keep 2 over 3 and then you change the division to a multiplication. Yep, you change it into a multiplication and you flip 4 over 5. So it's going to be 5 over 4. And then you just multiply, right? It's 2 multiplied by 5, which is 10, And 3 multiplied by 4, which is 12. That's your answer. It's 10 over 12. Same for any other thing. So you keep the first fraction, you change the division to a multiplication, and you flip the other fraction. And that's it. Now let's move on to converting between fractions and percent.
And also notice how you can simplify the ending answer. So if it's 10 over 12, it can also be simplified to 5 over 6. And usually you should simplify your answers, so try your best to simplify them. Now going into converting fractions into percents. So if you ever have to convert a fraction into a percent, all you have to do is divide the numerator by the denominator and then multiply by 100. And then if you're trying to go from a percent to a fraction, all you have to do is write the percent over 100, and then you have to simplify. So for example, if we had something like 1 over 4, so let me erase all of this so we can see, so I can have some more space to write this. So if we have a fraction 1 over 4, to make this a percent, all you have to do is divide the numerator by the denominator, which would give us 0.25, and then you multiply that by 100. And if you do that, you're going to get 25%. And if you wanted to convert this back, then all you have to do is write the percent over 100, so 25 over 100, which would give us 0, it would give us 0.25, but if we had to simplify it, we would get 1 over 4, right? Because 25 times 4 is 100. So that's how you convert something to a percent, and you can convert it back from a percent into a fraction. Really simple. So now let's get on to a couple questions.
Yep, these are to keep you get your practice. So for if you have a mixed fraction plus a mixed fraction, first you add the whole numbers. So it's 9 plus 10. I have 9 plus 1, which is 10. And then you just add the fractions by themselves. So 2 over 7 plus 3 over 7, it's 5 over 7. And that's your answer.
Okay, so now let's get into doing problem number 2, which is adding two fractions. So when we add two fractions, we need to make sure that the denominator is the same. And here, right now, it's not the same, because 7 over 4 plus 8 over 2 do not have the same denominator. So all we have to do is, first we make the denominators the same. For that, we can multiply. So 2 times 2 would give us 4. So we can multiply 8 over 2 by 2 over 2. Because remember, if we multiply by 1 over 2, that will not be right, because then that will make up a new fraction. So remember to always multiply the numerator and the denominator by the same number. And when we do this, we'll get 7 over 4 plus 16 over 4, right? And then all we have to do now is add the numerators and have the same denominator. So this will be 23 over 4. Simple, right? Kind of, pretty much. So that's it for question number 2.
Yeah. Now let's move on to question number 3. So it basically says 10 over 5 minus 3 over 2. So when you have something like this, it's similar to the addition problem again. You need to make the denominators the same. So what's the lowest common multiple for these? It's 10, right? So how can you make 5 a 10? You need to multiply them by 2. So just multiply this numerator and denominator by 2. So 2 and then 5 times 2. 10 times 2, 5 times 2. And then how can you make 2 a 10? It's multiplied by 5, same. Multiply the numerator. Oh, sorry. Multiply the numerator and denominator by 5. And that's going to be 20 over 20 over 10, so 20 over 10 minus 15 over 10. And that gives us, sorry, I'm taking a long time, but anyway, that gives us 5 over 10, right? And then if you see something here, you can simplify 5 over 10 further, right? You can divide both the numerator and denominator by 5, right? So what would that give you? 5 divided by 5 is 1, and 10 divided by 5 is 2. There we go. That's your final answer. So always remember that if you can simplify your answer more, make sure to do it. And in this case, you can, and that's why you got 1 over 2 as your answer. And since you can divide 1 over 2 even further, you would just put it in that as your answer.
Mm-hmm. So now let's move on to question number 4. This is a multiplication question, and like I explained earlier, multiplication is really easy. All you have to do is multiply the numerators and multiply the denominators. No other steps. So let me erase this real quick. And here, let me just write that answer. Right here so you guys know that that still exists. And then, so all you have to do for this is multiply the numerators, which will be 5 times 7 over 4 times 2, right? And 5 times 7 is 35, 4 times 2 is 8. Can it be simplified any further? Nope. So that is all it's going to stay at. So 35 over 8. Really simple. 2-second problem, right?
Now let's look at the next question. Here we have 11 over 4 divided by 7 over 5. So remember the rule for dividing fractions is keep, change, and flip. So we keep 11 over 4, we change the division into a multiplication, and we flip 7 over 5 into 5 over 7. And that's all. Now you do the same thing as you did in number 4. You just multiply 11 over 4, multiply it by 5 over 7. And that's going to be 55 over 28 in this case. And that's it. That's your answer for this question.
Mm-hmm. So now let's get into question number 6. So you probably just looked at one fraction and you go, wait, what's the question? So we didn't write down the question, so sorry about that. But the question here is convert 4 over 20 to a decimal. Now to convert this to a decimal, all you could do is simplify it and then divide. But another way is to make the denominator 100. And to make the denominator 100 for this would be to multiply the numerator and the denominator by 5. Because remember, 5 times 20 is 100. So that will just give us 5 times 4, which is 20, over 100. And when you do that, all you have to do is when you divide by 100, you know how there's a decimal point here, and then you just move it up 2. So that will give us 0.2. Now the other way you can do this is that you can just take 4 over 20. Okay, my microphone keeps muting. So all you do is take 4 over 20 and you simplify this. So when you simplify this, it's going to be 1 over 5. And then 1 over 5, you could just divide 1 by 5, which will give you 0.2. So either way, you get the same answer. The first way is easier. The second way is what you'd use probably later on to make it faster, because not everything can be multiplied by something to give 100, and it's not easy to find a number they can multiply by to give 100. So you can also simplify and just divide the numerator by the denominator. So just do long division and you'll be cool.
Yeah. And another thing is, let's say you have 0.2 given to you, like a decimal, and they ask you to convert it into a fraction. What you just do is you can multiply 0.2 into a 100. So that will give you a 20, right? It will get you back into a 20. So it'd be 20, and then you just divide that by 100. And then you just simplify this. And in this case, it's 4/20 because you divide it by a 5. And that's it. That's how you convert a decimal to a fraction. So you multiply it by 100 and you just put it divided by 100, but don't like actually divide it by 100 to get back into 0.2. Just simplify it even further, and that would be 4/20. And another thing I want to mention is when you have like a mixed fraction, like let's take the same example we had in the first question, the very first one, but you have like a improper fraction now. So let's take 10/7. 10/7, okay? So you might be wondering, oh, well, how am I going to solve this, right? It's like an improper fraction and a mixed fraction. Well, like we told you before, you can convert like this into a mixed fraction or this into an improper fraction and simplify it. So let's convert this into a mixed fraction and then simplify it. So it's 2/7. Just put that as it is. And then add, 7, what's the closest it could get? It's just ones, right? 7 times 1 is 7. And then 7 times 2 is 14. And that's over 10. So that's more than 10. You can do that. So just put 1. And then, that 7 times 1 is 7. So 10 minus 7 is 3. Just put 3. And the denominator as it is, so 7 in this case. And just do it as we did in number 1, and we will get your answer.
Mhm.
And that's it.
Yep, you could also do this the other way depending on how they ask you for the answer. So if they say something like, I convert this, so if they ask you for the answer in a mixed fraction, then you would convert this into a mixed fraction. But if they ask you for the answer in an improper fraction, then you convert the mixed into improper. So it depends on what they ask you. Now, that is all we have for you today. We learned about a lot of things, and this is really important. So remember all of this, guys. And if you want, you can always go back into the video, look at our explanations, and if you still have more questions, you can comment down below. We'll always look at the comments, so we'll definitely look at your question and reply and answer you and give you an answer. And if you're still confused about decimals or mixed fractions, which are the two things I've noticed people struggle in the most, then you can definitely reach out to us for help, and we will help you for sure. So comment down below if you have any questions. Go back into the video, watch it again, guys, have some fun. Math is fun, okay? And just calm down, relax. We don't have any assignments for you guys. So that's all we have for you today. See you in our next video then. Goodbye.
Bye, Stepsters.